So your Excel spreadsheet project that is due February 19th is going to take you quite a while to complete. So I would suggest starting as soon as possible. I'm going to go through how to accomplish this project as smoothly as possible in this video. So the instructions for it are in this assignment, and you can download these drawings right here. The drawing numbers are labeled here, and the title of the drawing is here. Pretty self-explanatory. Okay, I would highly suggest downloading these to your desktop and putting them in a folder. I will give you the hard copies of these drawings when we go face to face, and if you lose them, then you will have to print them on your own. I would highly suggest printing them in the 11 by 17 format, because that's going to be the easiest one to read. And I actually have a set myself. And they're a lot easier to read in the hard copy form. Your final project will be a hard copy of the drawings, and that's basically standard industry practice as well. Okay, so what are these drawings anyways? These are, and I have them all downloaded to my desktop already. These drawings are P&IDs, and P&IDs stand for Piping and Instrumentation Diagrams, and they're the secret to any power plant or ship. They tell you how the systems are built, and they're incredibly useful when doing lockout tagout programs, outage programs, planning for maintenance. When you first come to a plant, you're going to want to grab a set of these from the control room operator and walk down the plant using these drawings so you know where everything is. It's going to give you a great detailed picture of what is actually happening in that plant. So these are actually from the Athens to Old Town project, when they moved the Old Town mill from Athens to Old Town, and so that's why they all say preliminary on them. They're the first set of drawings when they were trying to figure out how they were going to do that. So these are real life P&IDs, and again, this is going to be a great exercise for you. So the first page of your project is going to be the symbols page, and this is going to be very useful for you to find out how to read these P&IDs. You're going to be flipping back and forth between the drawings and this page a lot to figure out what all the components mean. And I also want you to note, let's see here, if this will actually let me do this. The line designation has a number on it, and this number has specific designations for it. The first two numbers are the line size, the last two is the class. So this helps you further classify each line in the system. This will also show you what NO means, which means normally open valve, NC normally closed valve. The drawing numbers should be over here in the corner, 7711A. There's letter designations that you can figure out what they are from reading this function designation chart. Should be pretty straightforward. Okay. So the first one we're going to look at is the main and extraction steam picture, 7712. And what I would like you to do is pick a line, and for this example, we're going to use this line here. Let me move my picture out of the way. This line right here, it has a bubble around it because there were changes made to this P&ID, and they wanted to verify that you knew what the changes were. So this bubble means that it corresponds with this note. You can read that at your leisure. But let's continue on with the project. there's a number right here, and that number is different than this number, okay? This little symbol here ties into another point, which you will find on a different drawing. You need to pick one line designation, so for this example we're going to use this number, and you're going to follow that line and record all of the components on this line into a spreadsheet. And you're going to note the numbers on the valves and be very specific on what type of valve it is. This is a globe valve, and because it's dark, you can assume that's a normally closed valve. Its number is 806 HV-475. You will record that in your Excel spreadsheet along with this line designation. You'll record this line as well because it is part of this system. As we go through this line, and you can tell that the system flows in this direction due to the arrows, we can find a flow control valve, another drain line. You'll notice this valve has no number designation. I will not make you label valves that have no numbers. Here's a desuperheater that you'll need to record in your Excel spreadsheet. It only has XXXXX as its number designation. Go ahead and throw that into your Excel spreadsheet. This number is different than the one over here, so you do not have to record this line. And you'll also see there's a reducer here, no number. You do not have to put that into your Excel spreadsheet. And if you notice, there's a flange here, and this is a 900-pound line, and this is a 600-pound line. So this is a different line, and you can also see that by this number. So you can stop at this flange. So you'll be going through each drawing, labeling one line, and putting it to an Excel spreadsheet. I will also like you to highlight the line you choose so that it's easy for me to figure out which line you are classifying. So let's look at this Excel spreadsheet. So I want you to set up your spreadsheet exactly like this, and I will have this spelled out in the written document for this project. But your drawing number, system description, your line number, line size, component number, component type, checkout, hydro, lined up, label, installation, checkout complete. Now you're probably wondering what this second is about. These items will be received from your P&ID. This checkout is an example, like if you were actually in a plant, you would check out a line to make sure that it was ready to go, the work was completed, that it's ready for a hydro. A hydro is when they apply air pressure and water pressure to a line to make sure there's no holes in the line, that it's lined up correctly, it's labeled, it's been insulated, and it's ready to go. In this class, you're going to learn how to make the cells work for you. Basically, if I put yes, 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 yes here, this cell will automatically turn to yes. If it has a no with all these yeses, then it's going to automatically put false in. You're going to learn how to do that, and that is called a if and then statement. So that is part of the project. You will be learning how to do this as we go through the lectures and the assignments. So this is going to be kind of a build upon learning experience. It's very important too that you keep your project nice and neat. I would suggest making your labels a different color so they're easy to see. You're going to get graded on that. And to make sure that everything is on one page. So if there's a lot of information, make sure that it's on one page. Don't have it move over to a second page. It'll just be easier for grading that way. This project will be building on skills that you have learned throughout the semester. Again, it's going to take you quite a while because there are, I believe, there are 12 drawings that you need to itemize and put into a spreadsheet such as this. If you have any questions, please feel free to send me an email, stop by my office. And again, we'll talk about this in greater detail during the face-to-face sessions when we get back to that mode. And I'll probably check up on how you are doing on the projects as well once we get back. To review exactly what is needed on this document, double check the Canvas assignment. There's a rubric on there as well, and that will walk you through all of the components step by step so that you can get a really good grade on this project.